Hi guys, and welcome to another video. And in today's video lesson, we're going to be looking at grade 12 maths sequences, linear, quadratic, and sum to n terms of a linear sequence part 1. The question that we're going to be looking at is from the November 2018 paper 1, and it reads as follows. It says, given the quadratic sequence 2, 3, 10, and 23, write down the next term of the sequence, determine the nth term of the sequence, and calculate the 20th term of the sequence. Now in part 1, I'm going to be looking at answering these first three questions. Part 2, I will look at questions 2.2 and 2.3. So let's get straight into it. Now, what is a quadratic sequence? Quadratic sequence. It's very important for us to know the properties of a quadratic sequence. In a quadratic sequence, we have a constant second difference, and also in a quadratic sequence, the first difference is linear. So that's two very important things for us to know when they tell us that this sequence is a quadratic sequence. Now, just like in all sequences, this is what I do. I always write out my sequence again into a format that is easily understood by me so that I can answer any question that follows. So let's have a look at that. For 2.1, I'm going to write out my sequence as follows. So n will be I got 1, 2, 3, 4 terms there, so it'll be n will be 1, 2, 3, 4. Tn is the actual term in the sequence, and the terms are 2, 3, 10, and 23. So the first term is 2, second term is 3, the third term is 10, and the fourth term is 23. Then I will now work out my first difference, because remember that they tell me that this is a quadratic sequence, and I will also work out my second difference. So my first difference is simply 3 minus 2 is equal to 1, 10 minus 3 is equal to 7, 23 minus 10 is equal to 30. My second difference is calculated as follows. 7 minus 1 is equal to 6. 13 minus 7 is equal to 6. And now you can see that we have a constant second difference. Therefore, this is a quadratic sequence. But they told us that in the question. So now we can answer our first question. And our first question says, write down the term of, or the next term of the sequence. So in order to write down the next term of the sequence, what we do is we have to extend the first difference. And by working out the second difference, you can see that the first difference will be increasing by 6 each time. So 1 plus 6 is 7, 7 plus 6 is 13, therefore 13 plus 6 is 19, and 19 plus 6 is 25. Therefore, if you now want to extend or write down the next terms of the sequence, so let's say we want to write down the fifth and the sixth term of the sequence, 23 plus 19, and that will give us 42. And the sixth term, although they didn't ask us, 42 plus 25 will equals to 67. So now you can see, you can write down your answer for the next term of the sequence, which will be 42. So therefore, to answer the first question, the next term of the sequence, 2.1.1, we will write down our answer, which is 42. You can just write down 42. Now for 2.1.2, in this question they say, determine the nth term of the sequence. Now the nth term of a quadratic sequence is Tn equals to an squared plus bn plus c. And there's a set way in which we will find the values of a, b, and c. So let me just break it down for you. Now, when you have Tn, the general term of your quadratic sequence, Tn equals to an squared plus bn plus plus c. It's important for us to understand the following. To find a, and that will in most cases be our first step, we'll say 2a is equal to the second difference. To find the value b, we will usually do that in our second step. It's 3a plus b equals to t2 minus t1. And to find c, that will be our third step. That will be a plus b plus c is equal to the first term. So therefore, let's go and follow those steps. So looking at our sequence, we now know that 2a equals to our second difference, and our second difference is equal to 6. So therefore, we'll say 2a equals to 6 and solve for a. Therefore, a is equal to 6 divided by 2 is equal to 3. Then step number 2, 3a plus b equals t2 minus t1. So that will be 3 times 3. So we're taking a from our first step and substituting it here now, right? So there's a there. So it will be 3a plus b equals to t2 minus t1, and t2 minus t1 is your term 2 minus your term 1. 3 minus 2 is equal to 1. We can also call it the first term of the first difference. It's important to also note that the first difference of a quadratic sequence, as I've already mentioned, is an arithmetic sequence or a linear sequence. Often they also ask us to find the formula of the first difference. So therefore, the first term of the first difference is 1. So therefore, t2 minus t1 is equal to 1. Therefore, we've got 9 plus b equals to 1. b equals to 1 minus 9 is minus 8. Step number 3, a plus b plus c equals to t1. So a is equal to 3. b is equal to minus 8, so that's minus 8, plus c equals to t1, and the first term is 2. So therefore, we'll say equals to 2, and let's solve now. So 3 minus 8 is minus 5, plus c equals to 2, therefore c is equal to 2, plus 5 is 7. And there you go, learners. We've got a, b, and c. So therefore, the general term tn is equal to, value for a is 3, so that'll be 3n squared. Our value for b is minus 8, so that'll be minus 8n. Now value for c is positive 7, so that'll be plus 7. One thing I insist learners to do is to test out the sequence. So therefore 3, let's see if we get our first term of our sequence. So 3 times 1 squared minus 8 times 1 and plus 7 equals 2. So our first term is equal to 2. We can just double check that. So the first term is equal to 2. And let's quickly just go and check out the second term as well. So 3 times 2 squared, there, minus 8 times 2 plus 7, and that's equal to 3. Let's go and check that out. There you go. So you don't need to go beyond that. So now you're confident that your general term is correct. So now we can move on to the next question, which is 2.1.3. Calculate the 20th term of the sequence. So the 20th term of the sequence will be t20. So for 2.1.3, 2.1.3, t20 equals to 3 times 20 squared minus 8 times 20 plus 7 equals 2. So now wherever we've got n, we're going to substitute 20. 20 there and 20 there. And let's see, what do we get? 1047. So therefore the 20th term of the sequence is 1047. Learners, if you haven't subscribed, make sure to subscribe to JL Maths, my YouTube channel. You can also check out all the videos in order of the work schedule on jlmaths.com. And also like my Facebook page, Justin Lazarus Mathematics. And I'll catch you in the next video.